In this video, we will take a look at the basic concept of functions. Function is actually quite an abstract concept in mathematics. If we want to see some concrete examples of functions, Microsoft Excel is a good start. Suppose now I want to use Excel to round down a decimal number to the nearest integer. I can do something like this. I can type the decimal number I want here, and then I can type equal int bracket, and then I just type A2, it means the value in A2, and then press enter. And from this int bracket, I can round down this decimal number to the nearest integer. In this case, we describe that this number 2.8 is our input value, and this number 2 is our output value. If I change the input value, then the output value will be changed. Like this. Therefore, we say that these two numbers are variables because they will vary, their values will change, so we call them variables. And for this input value, because we can freely choose the input value that we want, so we call this input value the independent variable. And this output value is dependent of our input, so we call this the dependent variable. That means in this case, this int bracket helps us to generate an output value based on this input value. And this int bracket in Excel is called a function. And the meaning of this word function is exactly the same as the word function in mathematics. In formal terms, function means an input-output process that defines a relation of a set of input values and a set of output values. As mentioned before, the input value of a function is formally called the independent variable, while the output value of a function is called the dependent variable. The concept of function can be illustrated by this diagram. We have the input value called the independent variable, and then a function can help us to generate an output value called the dependent variable. The concept of function is actually very common in real life, but we just don't call it function in our daily life. For example, this is the parking rates of a car park in Hong Kong. When we are reading this parking rates, the hours of parking is actually like an input value. And then the parking fee is the result of these hours of parking, so this is the output in this case. That means in this case, if the hours of parking is 1, then our input value will be 1. And after parking for an hour, the fee should be $14, so the output value is 14. Similarly, if the input value is 2, that means the output value should be 2 times 14, which means 28. If the input value is 5, that means the output value should be 5 times 14, which means 70. If the hour of parking is 6, because the daily maximum is just $75, that means if the input is 6, the output should be 75. Similarly, if the input value is 7, the output value should be also 75. And if the input value is 8, then the output value is still 75. And of course, it is assumed that these 8 hours happen within the same day. In short, function is something that connects the input values and the output values. That means a function should be treated as a process that defines the relations between the input values and the output values. Furthermore, a function should have this characteristic. Each input value of a function can only result in only one output value. And mathematically, we usually use the symbol x to denote the input value, and we use the symbol y to denote the output value of a function. To understand this better, please take a look at this diagram. This diagram shows a relation between x and y. But is this relation a function? To determine whether it is a function, we should take a look at the input values x. Here we can see that each input value x will only give us one output value. That means the input value 1 will only give us the output value 3. The input value 2 will only give us the output value 3. and the input value 3 will only give us the output value 7. Even though there is no input value that can give us the output value of 5, it doesn't matter. It is still a function because each input value has only one output value. In this case, mathematically, we can describe that y is a function of x. Now let's take a look at another diagram. In this diagram, we can see that the input value 2 cannot give us any output. That means we should conclude that this one is not a function. Y is not a function of x. And then let's take a look at this diagram. In this diagram, we can see that the input value 1 can give us two possible output values, 5 and 9. That means in this case, it is not a function. Y is not a function of x. When we know that a relation is a function, mathematically there are three common ways to represent a function. Let's take a look at this parking race again as an example. To represent this function, we can use the tabular representation. Tabular means we use a table. In this example, the table should look like this. The left column is the input values, and the right column is the output values. Another way to represent this function is to make use of the algebraic method. That means we can use a formula to represent this function. In this example, if the hours of parking is x and the parking fee is $y, then we can say that when x is between 1 to 5, y is equal to 14x. And when x is greater than or equal to 6, y should be equal to 75. By using these equations, we can represent this function algebraically. The third common way to represent the function is to use a graph like this. When we use a graph to represent a function, the horizontal axis should be the independent variable, that means the input value, and the vertical axis should be the dependent variable, that means the output value. Talking about the graphs, we can actually determine whether a relation is a function or not by just looking at the graph. In this diagram, if I draw a vertical line like this, that means for this input value x, the output value y is located here. And if my input value x is here, that means my output value y is somewhere here. Similarly, if my input value x is here, then my output value y is here. From the graph, we can see that for any input value x, there is only one output value y. Therefore, we can conclude that in this case, y is a function of x. Now let's take a look at another graph. In this graph, if my input value x is somewhere here, then I will have two output values y. In this case, an input will give us two outputs, and this relation is not a function. Therefore, we should conclude that y is not a function of x in this case. Finally, let's learn some more terms related to functions. For functions, we have a concept called the domain. The domain of a function is the collection of all the possible input values of this function. Besides, we have the concept called the codomain. The codomain is a collection that contains all the possible output values of this function. And lastly, we have the concept called the range of a function. The range of the function is the collection of all the possible output values of this function. Codomain and range are similar, but they have a slight difference. Basically, we can have more than one codomain, but we can only have one range for each function. In secondary school, we're only required to find out the domain of a function. Take a look at this example again. In order to find the domain of this function, we should focus on the input values only. The input value in this case is the hours of parking, and we should know that these hours should be integers because when we need to calculate the parking fees, the time of parking should be rounded up to the nearest integer. Basically, we cannot have decimal numbers for the number of hours when we're calculating the parking fees. On the other hand, suppose now we are talking about the daily parking fee and the daily hours of parking. Therefore, the hours of parking should not be greater than 24. That means in this case, the input values can only be 1, 2, 3, 4, all the way to 24. As a result, we should conclude that the domain of this function is all positive integers less than or equal to 24. In other words, the domain is the collection of the numbers 1, 2, 3, 4 all the way to 24. To conclude, in this video, we have learned that a function is a process that defines a relation of a set of input values and a set of output values. Mathematically, we call the input value the independent variable and the output value the dependent variable. They are usually denoted by x and y respectively. In addition, we have learned that for a relation to be a function, each input value must have one and only one output value. And then for any functions, we can talk about the domain, the codomain, and the range of this function.